Hello, welcome back to my channel. This is the third video of my YouTube channel, and this video is about verification of a AND gate. I am going to verify using the IC number 7408, and I am going to use some resistors and one LED and breadboard. Before verifying it, I am going to show what is an AND gate. So AND gate symbolic representation is this. This is an AND gate symbolic representation, and truth table for AND gate, truth table. So there are totally two inputs. I am going to name it as A and B, and one single output, that is I am going to name it as Y. So truth table can be written as A, B and one output Y. Truth table can be totally two inputs, to 2 raised to 2 equal to 4. 4 type of combination are going to be appeared. So 4 type of combination can be written 2 raised to 2 4. So 4 is can be written as 0 0 1 1 0 1 0 1. So how to write these inputs? I was also not knowing it. Now I know it very clearly. I am going to tell you how to write it. There are totally 4 type of combination, that is 1 2 3 4. So to write this table, first you take, this is 4, so you make it as 2 zeros and 2 ones, that is 2 0 2 ones. Now again make it a half, that is 1 0 1 1 1 0 1 1. If there are 3 inputs A, B, C and one output, how you are going to divide it? Again 2 raised to cube. 2 raised to cube is going to be 8. So totally 8 inputs. So 8 is divided into 2, that is 4 4. So 4 zeros, 4 zeros 4 ones, and then again this 4 is divided into 2 parts, and this 4 is also divided into 2 parts, that is 0 0 then 1 1 0 0 1 1. Again this is divided into half, that is 0 1 0 1 0 1 0 1. So this is how you are going to form the truth table input formation. Now we are going to operate in the AND operation. So AND operation is nothing but a multiplication operation. A dot B is an AND operation. So when you multiply 0 into 0, it is going to be 0 0 1 0, and 1 0, that is also 0, 1 1, it is 1. So only at 2 inputs are high, the output is going to be 1. So this is an AND gate. This is an AND gate truth table, and this is a symbolical representation of AND gate. And this is a formula to calculate number of inputs, that is 0 1 2 3, totally 4 inputs. In binary formation it starts with 0 0 1 2 3, so it is going to be totally 4 inputs. So now I am going to verify it in this using the breadboard and one IC number is 7408, and I am going to use a resistor because I am having a battery of 9 volt. This IC can only sustain a 5 volts, up to 5 to 6 volts, but I am having a 9 volts, so that IC must not burst. I am going to use an 2 resistors, 2 or 3 resistors I am going to use so that IC must be safe. So let's start it. So I have already made a video on how to use the breadboard, but still I am going to explain how to connect it on the breadboard. So you already know that these lines are connected in this fashion, and this line are connected in this fashion. So this IC, I have to use these pins in separate lines and these pins in separate lines. So I can't connect it here, because if this is connected here, these pins and these pins are shorted. So not to happen, I have it is in here bracket, so I'm going to use it. So this whole pins I'm going to connect it here. This is connected in this way. It is now connected. See, this whole pins have this whole line. This one pin has this line, this pin has this line. In the same way, this whole pins have their own single lines, and this side also they have their own lines. Here it is a bracket. There is no connection between this spread and this spread, this end and this end. So this is separation between two ends. So these pins are connected in this way, and these pins are connected in this way. Same as we have done in the NOT gate, we are going to give one VCC and one ground. That is VCC at 14th pin and ground at 1 2 3 4 5 6 7th pin, ground at 7th pin. So we are going to give here VCC and here ground. So I will show the diagram of this IC. It is having a AND gates in it. You must be seeing a picture of IC on the screen, that it has totally 4 gates. It has totally 4 gates, and in the NOT gate there were totally 6 NOT gates, because there was only one input and one output. So it was having a 6 NOT gate, but this IC has only 4 AND gates, because 2 inputs and 1 output, that is 1 2 is an input, 3 is an output, and 4 5 is an input, and 6 is an output, and this is grounded. This side also is in the same fashion. You can see in the picture, it is shown clearly that how the gates are connected inside this IC. And every time you must remember that the 14th pin is an VCC and 7th pin is an ground, and totally in this side there are 7 pins, and this side 7 pins, totally 14 pins. Every time whenever you use an IC, first just connect this VCC to and positive volt of the battery. I am using here resistor to connect. It acts as a wire having a resistor. So I am going to connect it the resistor, and this line I am going to use it as a VCC, and this side I am going to use a line as a ground. For ground connection I am going to use one wire. For grounding I am going to use an wire. This is the line, so you can connect in this line anywhere in these holes. I am going to connect it here, and I am going to ground it here, and I have grounded it here. VCC I have connected this side and grounded this side. And for input I am going to leave 2 open wires. So for input I am going to use one blue wire. This is I am going to use as A. I am going to connect it to a pin 1, which is 1 pin put, and for other input I am going to use one more, that is red wire. You can use any wire. I am going to connect it at a B input. So this is A and this is B. So these are those 2 inputs which are open wires. We are going to give input for this 2 wires, and for output I am going to use this LED. So LED, the long strand of this LED is an positive and smaller one is negative. So this is the long and this is the shorter. So long must be connected to the output, that is 3rd pin of the IC. So I'm going to connect it here, and I'm going to ground it. I can ground it here also, and I can ground it at this place also. That is 7th pin of the IC. I can ground it, because 7th pin is also grounded here. So if I connect this LED here or here, it is same, because this whole line is grounded. So ground connection is made to this pin. It means this pin is already grounded, so I can use it as a ground here, or I can use this here also. It will give the same output, because it is the same. That is, it can be grounded here or it can be grounded here, because this is also a grounded and this is also grounded, because this whole ground is connected to this line. So this whole line is grounded now. So I can use the LED as here or here. So that LED must not burst, I am going to use one series resistor, because LED may burst because I am using a 9-volt battery. You must use 5-volt battery for the connections. I am using a resistor, so because then a 5-volt battery I am not having it. If you have a 5-volt battery, you use it, because there is no need of connecting this resistor. Now I am going to connect one more resistor to this LED, so that LED must not burst it. So I am going to remove this LED. First of all, I am going to connect an resistor to the third pin of the IC. That is 1 2 3, this pin, and I'm going to give it connection here somewhere. I can give it here. So this whole third pin came here. This whole line is now a third pin, and now I'm going to connect LED to that third pin. So largest strand of the LED is connected here. I can ground it here itself, or I can ground here. I must ground it here or here. At any one place you can ground it. So this is how you are going to do the connection. Now I am going to give a battery supply. Let's see how it works. So this is the battery supply I am going to give. That is, this red strand is an positive, and this is an ground or a negative pin, black color. So I am going to give positive on this edge of the breadboard. That is this edge. This line it is connected, no, this second line. So I'm going to connect it here. So positive is given on this side, and this negative I'm going to connect on this line. That is second line here also. That is on this side. So I have connected battery positive on this side and the battery negative on this side, or a ground. So now now I am going to show you the how is the actual circuit looking that I have connected in the breadboard. That is, I have took one end as an positive end of the battery. That is, I have took one end as a positive and other one as a negative. That is, one hand as a positive of the battery and other one as a negative of the battery. That is, this line is positive and this line is negative. So I am going to connect a IC for positive end, and the 14th pin for the positive end, and the 7th pin for the negative end. Then I am going then there is a AND gate inside the IC. That is this gate. So this is an AND gate. So for AND gate I am going to leave two open wires. So these are the two open wires, and for output I am going to connect one. First I have connected one resistor. Then for that resistor I am connected on one LED. So this is the LED, and this side it is connected with a positive end, and this side I have connected it to a ground. So this is a positive end and this is a negative end. So to verify, I am going to give it whether it has a 1, that is voltage. This is as 1 and this is as 0. So to verify it, I am going to connect it here or here. This is 0 1 connection and this is 1 1 connection. So this is how the connection looks actually. So you can verify any of the other gates in this IC. That I have verified first gate of the IC. You can verify second gate. That is, you connect these two inputs to the 4th and 5th pin and connect the LED to 6th pin. You can verify the same AND gate by using those pins, because there is also another gate. Totally IC contains of 4 gates. That is 4 AND gates it contains. So you can verify by that also. So verify our inputs. That is, first input I am going to give it as 0 0. So the output must be 0. That is, no LED must glow. So for 0 0 I am going to take this one wire and I am going to give this side. That is, I am going to ground it. So 0 is nothing but 0 volt and 0 volt. So this is 0, and this blue wire is one more output, so I'm going to give that also as an 0. So now both are 0, but LED is not glowing. That is first input is verified. Now for second input 0 1, the LED must not glow now also. So one input I'm going to give it as a 5 volt, that is I'm going to give some voltage to it, that is positive side. Now I have given it, and it is, this is 1 I have given. Now I am going to give it as a 0, that is 0 volt. So the LED must get off, that it is not glowing. So the second input is also verified. And then now third output I am going to give, I am going to make this as 0. Actually this is 1 and that is 0, it is not glowing. Again you can make this is 0 and that is 1, it is also not glowing. Just to verify I am going to show you how it is. Now I have given this as a 0. I'm going to put it here, that is 0, and this I am going to give it as 1. So this is as I'm going to give it as a 0, and this I am going to give it as 1. You can give it here. So it is not glowing. So both are 0 1. So it is still not glowing. Now the last, and this case is also verified because LED is not glowing. See, this is 1 and this is 0, this is 1 I am giving, but it is not glowing. In breadboard if you just touch the hole, it is going to give the voltage, but it is not glowing, means the third input is also verified. Now I am going to give the input has 1 1, so the LED must glow here, that is 1 1. A is also 1, B is also 1, Y must be 1, that is LED must glow here. So both I am going to connect it at this side. One I have touched is just, one more I am going to touch it. See, the LED is, the LED is, just you can touch it, it will glow. It is connected here purely, and one more you can just touch and verify. See, the LED is glowing. Both the inputs are 1 1 and the LED is glowing. So all the inputs of the AND gate are verified here: 0 0 0, 0 1 0, 1 0 0, 1 1 1. So this was the video all about. So that's it for today. Thank you.